Hey everybody. The last topic we're going to cover in this chapter is the multiplication formula and combinatorics. So essentially what the multiplication formula is telling you is the number of different combinations if you have two things. So for example, let's suppose you have 5 shirts and 4 pairs of pants. How many different outfits can you make, right? You're going to just multiply simply the 5 shirts times the 4 pairs of pants, and that will make the total number of outfits that you can possibly create, right? It's going to be 20 total outfits because each shirt can go with 4 pairs of pants. So 4 times 5 is going to be 20. So the example that they use here is they have 2-door, 4-door, convertible, and not convertible. So they have all these different things that you can do, and you just multiply them all together. So let's say now you have 5 shirts, 4 pairs of pants, and 2 pairs of shoes. If you wanted to extend this formula, you can do 5 times 4 times 2. So it's just simply giving you the number of possible combinations. So this is kind of heading down the idea of what combinatorics are. Okay. One of the last 2 formulas we're going to talk about is the permutation formula. What this is going to tell you is the number of arrangements you can make by selecting R objects. And by when I say R, I mean it's a number of objects selected from a single group of n total objects. For example, let's say you have 8 shirts. You want to come up with the shirts that you're going to wear over the course of the week. So 5 days. So R would be equal to 5. You're going to select 5 objects out of a total possible group of 8. How many different ways can you select 8 objects? Or sorry, how many different ways can you select 5 objects out of a group of 8? The permutation formula is going to tell you this. So it's going to be defined by n factorial. Factorial is a really fancy way of just saying multiply n times each successive number after it all the way down to 1. So for example, in our case, n is going to be equal to 8, right? So we have 8 total shirts. So if we do 8 factorial, that's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's going to be that whole big multiplication. It's kind of a messy process, but what I'll do usually if I had a board here, and I'll do this in class, is I'll write down each of these numbers multiplied by each other on the top half of the fraction. Now on the denominator, we have n minus r factorial. So n is equal to 8, r is equal to 5 in our little shirt example. So we'll have 3 factorial. This is just going to be 3 times 2 times 1. So you can actually see how if you have 8 times 7 times blah, 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 times 3 times 2 times 1 on the top, and on the bottom you have 3 times 2 times 1, you can actually just cross out the 3s, cross out the 2s, and cross out the 1s. That's why I like to write it out like that, because then we can very easily just cross it out. So the math looks complicated, the formula looks complicated, but it's really just how many different combinations can you make? So another way to think about this is if you have a blue shirt or red shirt and then all the different color shirts, a different permutation would be red, blue, and then the other 3 shirts. A different one would be blue, then the red, right? So you can have the red shirt and the blue shirt be in any given position, and these are all going to be new permutations. So in this case, the order does not matter insofar that you can have the same exact 5 shirts in a different order, and these are different permutations. So the permutation formula is going to produce a fairly large number, or maybe a relatively large number. Relative to what? Relative to the combination formula. What the combination formula is saying is that, okay, you have 8 shirts, you want to pick 5. Great. However, what this combination formula is going to do is it's going to say that red, blue, green, yellow, black shirt permutation is going to be the exact same as if you shuffle those colors around. So if you had green, black, yellow, red, blue, that's going to be the same as the first combination. So, or the first permutation. So combination is actually going to be a relatively smaller number than a permutation, because order in this case does matter, and you do not want to double count the same combinations, even if they're in different orders. So in this case, it's just how many different combinations of 5 things can I pull. So again, this formula is going to be very, very similar. The only difference is you're going to have r factorial. So before we had 8 factorial divided by 3 factorial. Now we have 8 factorial divided by 5 factorial times 3 factorial. So once again, you can cross out 5 times 4 times 3 times 2 times 1 on the top and bottom, and then you're left with 8 times 7 times 6 on the top, and on the bottom you're left with 3 times 2 times 1. I know it's a little bit hard to kind of visualizing in your mind, but we will do this on the board in class. So that's all I have for this chapter, and hopefully we'll be back in class soon.